The purpose of this tutorial is to demonstrate what the derivative of the cosine function is. And remember, a derivative is an instantaneous rate of change. And so what I'm going to do is I'm going to take this, and this is the cosine graph, and I'm going to draw a bunch of tangent lines at different points over a full cycle. So I'm going to start here, I'm going to end right up there. And the horizontal axis here is actually measured in radians. So you might see numbers like 1, 2, 3, 4, 5, 6, etc. But for example, if you remember any trigonometry, in radians, of course, that point there is actually supposed to be pi over 2. If you take pi and divide it by 2, the number pi, 1.57. See, that's actually 1.57. The middle of the cosine graph here is below pi. See, 3.14 is pi. Where it crosses here is actually at 3 pi over 2. So if we do 3 pi over 2, that's about 4.7. See, that's 4.7 there. And then 2 pi, the end of the cycle, is at 6.28, which is above that number there. So even though you don't see any pi's, this horizontal axis is in radians. And so what I'm going to do is I'm going to draw several tangent lines, and I'm starting at the beginning of the graph here. So you see, there's my tangent point right there. So this would represent the slope of the tangent at 0, because that's where 0 is. So I'm going to kind of trace along the curve here, and so see, my point of tangency would be around here, so around 0.55, 0.6 or something like that. And then I'm just going to keep on going. Actually, let's unhighlight that. So I did that. So let's maybe do around here. That's a little bit too steep. Yeah, so that's probably about right there. And so let's unhighlight that and draw another one. Okay, so I'm trying to get a tangent right at that point right there. And let's do another one over here. Okay. Okay, so my tangent point's probably around right there. And then we'll do one right at the bottom here. So, of course, this one's horizontal, you can see. Tangent right there. And let's see here. Yeah, so there's my tangent point around there. And, oh, that one wasn't very good. But I'll change the... See, no, I just did right there. I'm kind of aiming in the middle here. Actually, maybe I'll aim for that point right there. Yeah, I think I need to change its steepness a little bit. It's pretty good. Okay, that's, well, we can edit that guy. Want to be a little bit before that, just a little bit. That's pretty good right there. So this last one I'm going to do here, so you know it's going to be horizontal again. So something like that. There we go. That's pretty good. Okay, so what I'm going to do now, I'm going to go back to the beginning. Okay, so I finished, see, at the end of the cycle at 6.28 or 2 pi here. And I'm going to measure the slopes of each of these. So I did that one. Measure, oops, gone. Measure the slope. Kind of have to unhighlight and then measure each one slope. Do this one now, measure the slope. See how I just did this one here, so I think my next one, 1, 2, 3, 4, yeah, okay. A little further on here, right there. So measure the slope. Did that one, so this one's next. Measure the slope. Okay, so I've done that one. My next tangent point's about right there, so that's this line. Measure the slope. Done that one, so I guess this one would be next, the one right there. Measure the slope. I got two more to do, so the tangent line right there. Measure the slope. And then the last one. Measure the slope. There we go. Okay. So what I'm going to do now is I'm going to plot the slopes as the y value or a function value. Now, for each of the x coordinates that point at tangency. So for the very first one, the point of tangency for the AB one was right here, and the slope was at 0. So I'm going to plot. Now there's a lot of points on here, so I have to kind of remember what's what. So the slope of that is 0, so that's my function value right there. So we'll put a point right there. And then CD, the tangent, it's probably about right there, around 0.6 or so. The slope is negative 0.5, so put point about right there. And then EF, let's see now, EF is this one, so there, I had it there. Those two are pretty close. It's kind of hard to see a little bit. Yeah, it's probably around there. EF is negative 0.86, so yeah, something like maybe that. And then the GH is the next one. GH. That's this one right here. So that one, let's see now, GH. They're so close it's hard to see. It's pretty close to right there. We're down at about, well, it's pretty close to negative 1. So, around there. There we go. And then IJ is the next one. So IJ is this one. Here's my tangent point here. Negative, it's about 0.6. So they're about negative 0.6. We'll put a dot about right there. And then KL. So KL is this horizontal one. Tangent point's about right here. We'll write it pi actually. And then MN. So MN is this one. So pointed tangency is about right there. And MN's slope is 0.6. So right here we'll go up to about 0.6. About there. And then OP. So OP is this one right here. So OP, okay, so it's pretty close to 1. So that's OP. So we're about right there. And then QR, 0.64. So, QR is this one. So my tangent is about right there. So we're at 0.6 approximately. So I'm going to come down a little bit. So we're around there, I guess. And then ST, its slope is 0. So ST, which is the one I did right at the end here, would be at 6.28. We're back down to 0. So what I'm going to do now is I'm going to take a picture of this. Everything went kind of gray here, but that's okay. And I want the whole thing pretty well. And that's pretty good, I guess. And I'm going to draw this by hand, so you have to kind of bear with me because this isn't perfect. But I'm going to plot all those points. So I'm going to start here. I'm going to draw a curve through all the points. I already plotted them, sorry. So something like this. And then, let's see now, it goes up like that. And we'll keep on going. So up about right there to that. And then I just missed that point. Something like that. Now, if you think back to what trig functions, the sinusoidal functions look like, this is actually, so we started with the cosine function, y equals cos x. And we actually grafting the derivative. This is actually the negative sine function. And maybe I'll do the sine function in blue here. Remember, the sine function looks like this. 0, 0. Okay, at let's see now, pi over 2, it's up at 1, which is around there, and then it crosses right here, and at 3 pi over 2, it's down at -1, and at 2 pi, it's back to 0. Let's see if I can draw this fairly accurately. So this is my sine function, sine x function. Oh, I was close there. I'm pretty happy with that. So that's the sine function. See, the black one that I graphed a moment ago is its reflection in the x-axis. So again, we started with this guy, the cosine function, and so we graphed the slopes of a whole bunch of tangent lines for it between 0 and 2 pi, and we got this function. So that would lead us to believe that the derivative of the cosine function is the negative sine x function. So that's what this investigation is supposed to demonstrate. And that's the end of the tutorial.